The third element on the periodic table of elements is lithium. This is North Teaches Science. With me, Mr. North, another physical science edition video, and today we're going to talk about calculating density. So your video goal is I can calculate density of objects using the density formula and applying density to real-world examples. So what is density? If you notice, if you've watched these videos before, I start off with the definition almost every time. Density is a measurement, but it's a calculated measurement. So you have to take mass per unit volume. So we have a formula here. The formula is density equals mass divided by volume, or big D equals little m divided by V, where the big D represents density and its unit is either grams per milliliter or grams per centimeters cubed. M is the lowercase m represents mass and its unit will be grams, and V is volume and its unit is milliliters or centimeters cubed. The reason why density has two units is because volume can have two units depending on if you're finding the volume of a liquid, try and find the volume of a regular object, or you try and find the volume of an irregular object. If you did not watch the video on measurement types where I talked about how to solve and find the volumes of those objects, I would go watch that before you come back to this video. All right, so the density formula. And when I teach physical science, I teach all the formulas in something called the triangle method. So this is the density formula in the triangle. The M at the top and the D and the V at the bottom. Reason why is because values next to each other will be multiplied and values on top of each other will be divided, and you go top divided by bottom. So what we do is we fill in the triangle and then we know which method we should do. It's easier than manipulating the formula before plugging in the numbers. Now, why do we need to know density? Density is really important about sinking and floating. Sinking and floating determines density, and we know that the density of water is 1 gram per milliliter. So you can compare an object's density to the density of water to know if it's going to sink or float. If the object's density is greater than water, which means greater than 1, it will sink. But if an object's density is less than water or less than 1, it will float. So think of things that will need to be, think of things that you have placed in water that sank and that float, and now you can kind of know about their density. All right, let's solve density now. Let's look at 4 problems and solve for density. So we have this problem here. It says, what is the density of a piece of wood that has a mass of 25 grams and a volume of 29.4 centimeters cubed? When you do this, the first thing that you want to figure out, ask yourself, is what am I trying to find? And what you're trying to find is density. So we're going to place that letter in the triangle. That letter is the big D, and it would go right here. That means the other numbers other stuff given is going to go in those other empty plots. At the top up here from the formula, if you remember, D, M, V, that's how I remember it. Mass at top, volume at the bottom. So the mass here was 25 grams, so I'm going to write 25. And the volume is 29.4. Now that we know that, we can solve this. The numbers are on top of each other, so we're going to divide. We're going to do 25 divided by 29.4. So this would be a good time to have a calculator out. And so when you do that, you get 0.85. And that's the value of density, but density also needs to have its unit. We know that density is always a gram over something, and then we look at what the unit for volume is, centimeters cubed, and it's grams over centimeters cubed. And this is the answer. Now, it was like 8.5, a bunch of other numbers. I usually do 2 decimal spots afterwards. So this was density practice number 1. I want you to pause this video real quick and try to find the density here. 5, 4, 3, 2, 1. All right, let me solve it with you so you can check your answer. It says a 30 milliliter sample of a liquid has a mass of 50 grams. What is the density of the liquid? What are you trying to find? We're trying to find density. So we're going to leave the D in the triangle. At the top goes a mass. According to the problem, it says mass is 50 grams. And then it says the volume is 30. It doesn't say volume, but volume is milliliters, and it's also the only other available number out there. So how would we do the math? Is this 30 divided by 50 or 50 divided by 30? It's 50 divided by 30. So if we do the math, we get 1.6 repeating. So I'm just going to do some rounding, 1.67, and it's grams per milliliters. All right. Hope everyone's followed along so far. Let's make it a little bit more complex. It says a block of wood has the measurements of 3 centimeters by 6 centimeters by 4 centimeters. The same block of wood has a mass of 80 grams. What is the density of the wood? Does it sink or float in water? So we are first asking, what are we trying to find? Well, we have two questions, but the thing that we're focused on right now is density. So we're going to leave D in the equation. At the top goes our mass. According to this, it says our mass is 80 grams. Now here's volume. Does it give us volume? It doesn't say volume is this. It doesn't. Don't have milliliters or centimeters cubed, but it gives us 3 measurements. And we know that it's a block of wood. Block of wood are regular objects. So volume is equal to length times width times height. So we're going to do 3 times 6 times 4. And we do that in the calculator, you get 72 centimeters cubed. And that 72 goes in the empty box. Then we do our math. We do 80 divided by 72 because they're on top of each other. We get 1.11 repeating grams over centimeters cubed. That was the first question. We found out what density is. The next question is, does it sink or float in water? What's the density of water? It's 1. Is this number greater than or less than water? Well, it's greater than water, so it's going to sink. If it was less than water, it would float. All right, the last density problem. It says a rock is placed in 10 milliliters of water, causing the water level to rise to 25 milliliters. The same rock has a mass of 7 grams. What is the density of the rock? First thing we need to figure out, what are we trying to find? We're trying to find density. So we're going to leave D in the triangle. The top goes our mass. According to our thing, it says mass of 7 grams. Now, it doesn't say in here that the volume is this, and it gives us 2 different values for milliliters. When this comes up, what this is trying to do is cause water displacement. So your volume will equal your higher milliliter minus your lower milliliter, which equals 15 milliliters. And that 15 goes in the triangle. Then we solve. 7 divided by 15, because the numbers are on top of each other, we get 0.47 grams per milliliter. I want to add a question. Would this sink or float in water? Well, the value is below 1, so it would float. There is a rock that floats. Now, why would we need this to know density other than sink or float? Well, density can form layers. So when liquids are poured together, they will separate into layers based off density. At the top will be the least dense liquid, while at the bottom here, you're going to have the most dense liquid. So the honey is the most dense, so it's at the bottom. Lamp oil is the least dense, it's at the top, and they are layered based off their density. You also see objects in here and how they would react in different things. Not just can you compare an object's density to that of water, but if you know an object's density and a liquid's density, you can see if that object will sink or float in that liquid. So if you see here a popcorn kernel, its density is more than lamp oil, rubbing alcohol, vegetable oil, water, dish soap, milk, and maple syrup. So it sinks through all of them. But its density is less than corn syrup, so it's going to float on it. And same thing for honey. And so this is density and layers and how to use it. This is how you calculate density. Density is really important when doing measurements. I would go out there, try to get some more examples in density, try to practice this on your own. But I hope you learned something today, and I'm Mr. Norris, and I'm out.